Hi, my name is Hillary Chu, and today we'll be doing a slideshow that is brought to you by Mate Center Presentations that was originally presented by Matt Gardner. What is an ROV? An ROV is a remotely operated vehicle, also called an underwater robot. Remote stands for that the pilot is not in the vehicle, and operating means that the vehicle is controlled by a person. The vehicle itself means that it contains an integrated system. ROVs come in many different shapes and sizes. They have small observation vehicles that may only be 30 to 40 centimeters long and only have a camera used to look around in the environment. They also have large work ROVs that can be compared to the size of a house or a semi-truck and have many complex tools. In an ROV, there's different types of systems. We have the structure or the frame that holds all of the ROV parts in a functional spatial arrangement. And we have buoyancy, which adjusts the tendency of the ROV to float or sink. Propulsion, or also known as thrusters, provides propulsive forces needed to move the ROV through water. And power, which provides power to the ROV and associated equipment. The control allows pilots to control the thrusters, tools, cameras, lights, and other subsystems on the vehicle. The navigation sensors are cameras or light sensors provide pilot with information about where the ROV is and what it's doing. A payload can be a gripper for picking up things, a set of tools for working underwater, or whatever capabilities are called for by the mission. And the tether transmits data and power between the ROV and the surface. Here we have two pictures of two different ROVs. On the left, you have a very expensive, almost $90,000 ROV that is used in the real world to go underwater and explore and complete different missions. On the right, you have a smaller ROV that is used in mate competitions. And even though it may be smaller and much cheaper, they have many similarities. For example, they both have a frame. One might be much larger, but they're still frames. And they each have buoyancy. On the right, the buoyancy is shown with the floaties, and on the left, it's the yellow foam blocks. In addition to buoyancy, they each also have propulsion. They have motors that allow each vehicle to move around in water. And the tether, which is connected on both ROVs, allows a control system to control the ROV from above the water. ROVs are used in a variety of fields. Some examples are scientific research, underwater archaeology, homeland security, pipeline inspection, and more. ROVs go where it is too dangerous, too deep, too dark, too dirty, or too undesirable to go. This way, humans aren't having to go into dangerous situations. For example, they go deep into water beyond a few hundred feet, or even inside nuclear reactors. Modern ROVs can do any task a diver can do. They can go deeper and stay down longer and do not need life support systems. ROVs are designed with a mission in mind, but sometimes must do other tasks. For example, explore the ocean on Jupiter's moon and Europa, or something like rescue trapped submarines. Some examples of things you may do on the day of a competition at a Mate ROV competition is that you can pick up crabs and urchins from the seafloor, or remove a corroded section of pipe and replace it with a new one, or even using a manual pump to fill a lift bag to assist in retrieving rock samples from the seafloor. To pick up crabs and urchins, you have to remove as many urchins and crabs as possible from the seafloor and return them to the surface, or in this case, the side of the pool. Another example that you would see at a competition is when you're replacing a corroded section of a pipeline, you would design a tool to grab the U-bolt that is on the pipeline and remove it from the stand it is resting on. Then you would replace a new segment of pipe onto the stand. This represents what you would do in real life when there is a need to replace a pipeline. Another example would be retrieving a weighted sensor from the seafloor. You would use a manual pump to fill a lift bag and bring up a 2-pound weight to the surface. During the competition, Mate would usually provide a pump for you. Some other objectives are to try some other vehicle designs and to fly some other vehicles and compare them to your own design. This way you can see the differences and the strengths and weaknesses of your designs and other people's designs. Another objective is to be creative. Think about how you could do something differently. Consider how you would do it if you had more technology and how you could get something done with less technology. And lastly, but the most important objective, is to have fun. Thanks for watching this presentation. Don't forget to like and subscribe. If you have any more questions, you can go on the MATE website or look up www.fusebreakers.org to see more of our videos. Thanks for watching.